Now that you are able to identify the different classes of compounds and decide if things are soluble or insoluble, and know that when things do dissolve, what kinds of particles are present, we can now focus on one of the properties of solutions or mixtures, and that is the property of being an electrolyte. But first, we need to know what is an electrolyte. Can you think of any electrolytes? Most people may have thought of Pedialyte, which is used for children to replace their electrolytes when they're sick, and Gatorade, which is used in athletes for when they've lost their electrolytes. Let's look a little closer at Gatorade. Here's a typical Gatorade ad. It says, rehydrate, replenish, and refuel. So what are the ingredients that are present, and what does this have to do with electrolytes? Let's look at the ingredients. First we see water, which of course is going to help us to rehydrate. Then we see sugar, which is also known as sucrose, dextrose, also known as glucose. We have citric acid, some natural flavors, salt, sodium citrate, monopotassium phosphate, a modified food starch, glycerol ester of rosin, and blue 1. So some of them are very easy. Natural and artificial flavors are obviously used to flavor things. The modified food starch and the glycerol ester of rosin are used to change the texture slightly of the Gatorade, so those are not part of the rehydrate, replenish, and refuel section. And finally, we have the blue 1, which is to color. It's to make it look blue. In this case, this is for a blue Gatorade. So now let's look at the rest of them. We have water, sugar, dextrose, citric acid, salt, sodium citrate, monopotassium phosphate. And those are the ingredients that we'll look at for rehydration, replenishing, and refueling. I'm guessing that everybody knows that the water is used to rehydrate. Obviously, hydration has to do with water, so it's used to rehydrate. The refuel is going to be your sugar and your dextrose. They're going to give you energy for doing whatever sports you need to do. The citric acid has two uses. It can be used to flavor, so it tastes a lemony flavor, and it can also be used as part of the replenish. And specifically, what's being replenished is your electrolytes. That is also going to be done by the salt, the sodium citrate, and the monopotassium phosphate. Notice that all of those are ionic compounds, and so we're going to see how they work as electrolytes in the next section. If you just wanted to rehydrate and refuel, you could use Kool-Aid. It would have the nice color, it would be nicely flavored, it would have water in it, and it would have sugar in it. So why do we need to replenish? What do these electrolytes do for our body? Before we look at why electrolytes are important, let's define what electrolytes are. An electrolyte solution is an aqueous solution that conducts electricity by virtue of the movement of ions in the solution. For this to happen, that means there has to be ions present to carry the electricity. When we talk about the substances that are electrolytes, we're going to talk about substances that form ions in water. And so we can have a strong electrolyte, which gives lots of ions, a weak electrolyte, which doesn't give very many ions, and a non-electrolyte, which gives no ions at all. We'll start with the definition of a strong electrolyte as any substance whose water or aqueous solution conducts electricity strongly. How do we know if something's conducting electricity strongly? The way that we do that is we're actually going to take a container filled with the substance dissolved in water. Into that solution, we're going to dip two electrodes. One will be the positive, one will be the negative, and what we're going to do is we're going to hook that up to a battery and a light bulb. So without dipping it, it'll be dark because there's no connection. As we dip this into an electrolytic solution, the light bulb will glow due to the ions carrying the electricity from one side to the other. How brightly that light bulb glows will depend upon how many ions are present. So we're going to allow the electrons to pass from one side to the other, going through the solution, then up through the light bulb, and it brightly glows if there are lots and lots of ions to carry all of those electrons. And then the electron goes back to the battery, where the electrolyte solution has closed the circuit, kind of like a switch. And of course, the more ions there are, the brighter this will glow to some point. The substances that provide many, many ions are the ones that are 100% ionized in water. And those three groups that we see are the soluble salts, because they're already ionic. They're going to be 100% ions when they're dissolved in water. Notice that they have to be soluble so that they do dissolve in the water. Next, we have the strong acids, which start off as molecules but ionize 100%, turning them into ions. And then we have the strong bases, which again are already ionic, 100% ionic. And since those strong bases are soluble in water, that means they give 100% ions in the water. Now let's look at the weak electrolytes. Weak electrolytes are any substance whose water, aqueous solution, conducts electricity weakly. That means it is not a strong conductor. That means that there are only a few ions present. And again, when we observe this, we're going to make an aqueous solution, dip the two electrodes in that are connected to a battery and a light bulb, and we will see that when it conducts electricity, the light bulb just barely glows. That is because there are very few ions to conduct the electrons from one side to the other. So which substances are weak electrolytes? Weak electrolytes are the ones that only partly ionize, and that only happens for us with the weak acids and the weak bases. Strong acids and strong bases are 100% ionized, but weak acids and weak bases are just a little bit ionized, often less than 10%. So those are the only substances, the only two classes that we're going to look at that are weak electrolytes. And that leaves us with the non-electrolytes. Non-electrolytes are any substance whose water, aqueous solution, does not conduct electricity. These include both non-ionizing molecular substances, so those would be like carbon dioxide, those types of substances, molecular compounds that do not form ions, and anything that is insoluble in water. So if you stick it in water and it does not dissolve, it is a non-electrolyte. And that, of course, includes the insoluble salts and the insoluble bases. So be careful when you're looking at the solubility rules. You need to realize if it's insoluble, that means it is a non-electrolyte. And if it's a covalent compound, it is a non-electrolyte. Probably most of you have heard that you shouldn't dry your hair or listen to a radio while you're taking a bath. And the reason for that is because of this electrical conductivity. So if the radio drops into your bathtub for some reason, you could become electrocuted by the electrical conductivity of the water. Theoretically, if you used deionized water, something with no water, and you completely cleaned your bathtub, it would not happen because you have to have something that conducts electricity. But none of us clean our bathtubs quite that well, probably, and would not risk taking the chance. We don't want to have any electrical conductivity if you were to drop something in. So please beware not to use any electricity next to your bathtub, and that is because of the electrical conductivity, especially of any salts that are in the water. Notice that tap water by itself, not purified water, but the tap water does have salt dissolved in it, and since it has plenty of electrolytes in it, it can conduct electricity and you can be electrocuted by your radio falling into the bathtub.